Allow me to unbox for you a piece, or perhaps pieces, of Mars. This is Martian dust. Let's zoom in a little bit. How in the world do I have Martian dust? NASA has never sent astronauts to Mars. Our rovers and landers and orbiters from there have never returned anything from Mars. How in this little vial do I have Martian dust? Well, this Earth and solar system have been around for 4.6 billion years. That is a long time. We know that the dinosaurs died off, or were at least finished off, by a 6-mile wide asteroid or comet about 66 million years ago. And honestly, when considering 4.6 billion years, that's really not that long ago. We know that this planet has been hit by a lot of asteroids and meteorites, and so has the moon. Well, so have other places in our solar system. How about Mars? Come on, focus. So, picture this. A large asteroid or meteorite, whatever you want to call it, comes in, hits Mars, blows off pieces of Mars. Those pieces then float around our solar system for millions of years until they find their way to planet Earth. This is not that unheard of. Or how do we even prove that? How do I have a meteorite and say, okay, this meteorite, where is it from? It's from the moon, or it's from Mars. Well, that's because we can look at the chemistry, in particular the isotopic chemistry or ratios of elements to each other in certain types of minerals, to try and figure out where things have come from, almost like a chemical thumbprint. Luckily, we have been to Mars with rovers and landers, and they have studied the chemistry there, and we can we have those thumbprints to go off of. So when we find certain meteorites and test them, we may discover that, whoa, this isn't just some random piece of whatever from the asteroid belt. This is actually a piece from Mars, or this is a piece from the moon. There are lots of meteorites that we have that are actually chunks of the moon that have broken off, that were blown off of the moon and ended up landing on Earth. It's not that crazy to think that the same thing happened with Mars. However, we don't have very many of them. I kind of have seen conflicting numbers as I just kind of took a look at it. When this was, I think, when I first obtained this, I think there was only around 60, maybe less, and now I want to say there might be upwards of around 300. That's not very many. So what is this doing here in this vial? And you may be wondering what's this written in here? Basaltic shergotite. Okay, anybody with just basic geology knowledge knows that basalt is a rock. Well, that's what this is. This is a ground up piece of basalt, but it's a piece of basalt from Mars. Shergotite is a certain type of, basically a certain type of meteorite or a certain type of rock, kind of classified from Mars. The majority of the Martian meteorites we have are basaltic. Come on now, are basaltic shergotites. What's it doing in this vial? Well, basically, the actual meteorite, which this is not it, this is just a random meteorite, if it's even that, might be a tektite, was ground off to put through kind of a chemical process and a mass spectrometer to study its composition. And this is some of the leftovers from that were given to me by a former student's professor who works on this, who I'm not going to publicly name. And that's kind of how I ended up obtaining this dust. If you look at the kind of serial number here, NWA 2975, that stands for Northwest Africa 2970 2975. You can look this up on a database. And it was a meteorite that was found in Algeria, and I think now sits with either. I think the actual meteorite is at Washington or University of Washington, or university in Arizona, Northern Arizona University, maybe Arizona State. I'm not sure. I have to look it back up, but yeah, that's how I have Martian dust, which is this is not something you randomly find. Uh, and the my random students and random people will ask, how much is it worth? I have no idea. It's hard to prove that's exactly what I have here. I'm certain this is exactly what I have based on the person that I got this from. This person actually wrote one of my textbooks. I used it in graduate school. Um, so yeah, I have no idea. That this is effectively priceless because it's not like there's pieces of Mars floating around, and I don't even know how you'd sell this thing, and that's not what I'm about. I have it now for now. Eventually, I will. I'm a community college professor in Northwest Arkansas. My hopes are that Northwest Arkansas will kind of get in gear and build a fairly substantial science museum, or something I'm kind of working on with NWA Space. And when they get a facility, I will be donating this to that facility, and I'll probably decide with them uh, how it'll be used and how it'll kind of be shared with the public because that'll be its job. But yeah, I just thought I'd share that and kind of talk about, how do we have pieces of Mars even though we've never brought anything back? Well, there are meteorites out there that have been blown off of Mars. Not very many of them. In the millions and millions of meteorites we have that we found, there's only just a few dozen that look like they're from Mars. But I just happened to have someone kind of wanted to share what that looks like. And one last little thing, it's kind of an intersection of art and science. You'll notice this is a blown piece of glass. So the scientists that were studying this actually blow glass and create their own little glass tubes to collect this material and keep it perfectly shut off. There's no way to contaminate this, right? I can't get this out of here without breaking this glass, luckily, which I think is pretty cool. So yeah, hopefully you think that's kind of nifty. And if you're one of my students that's watching this, every now and then some of my really, I kind of judge my students. I'll kind of gauge them, and I'll pull some aside that I think may be interested in this type of thing, that do well in my class even this semester, and I'll show that to them. But yeah, hope you thought that's kind of nifty and got something out of it.